Welcome to a quick review of slope-intercept form of a line. So the idea here is every line that is not vertical can be expressed in what is called slope-intercept form. In algebra, this is typically written as y equals mx plus b. In statistics, we are going to change it up, use a slightly different format, but it's the same thing. In statistics, we will use y equals a plus bx. So in y equals mx plus b format, the b tells us what is referred to as the y-intercept. The y-intercept is when x equals 0, y equals that number. So in this case, y equals b. Or in terms of the graph, if you have the actual x-axis at x equals 0, then it's where it hits the line hits the y-axis. It's where the line hits the y-axis. So where the line hits the y-axis. The m is our slope, and it tells us our rate of change. Essentially, it tells us how much we move up for every one we move right. So for each step to the right. So over here, for statistics, we have y equals a plus bx. It's the same idea. When we have numbers in, obviously, we won't notice a and b at all. But this is the general way we order our equation for statistics. So in this case, the number without the x is the first one, our a. So this is our y-intercept. So when x equals 0, y equals a. Basically, if we take the number not touching the x, that's our y-intercept. And then the number touching the x is our slope. So we often see this as rise over run. So slope equals rise over run. So in this case, if we just put a 1 underneath, b over 1 is the same as b. b divided by 1 will stay b. So the top would be our rise. The bottom would be our run. So let's go ahead and just look at an example of how we could draw a graph based off of a line and slope intercept form. So if we have the line y equals 2 plus 3x. This is in the statistics format, right? The number paired with the x comes second. The number without the x is our y-intercept. The number with the x is our slope. So we have when x equals 0, y equals 2. And we have our slope is 3. We can always throw the 1 underneath. So we have a rise of 3 and a run of 1. If we graph this, one. So our y-intercept, when x equals 0, y is 2. Right? So it falls on our y-axis, hence the y-intercept. And then our slope, we have a rise of 3. So from that point, we will go up 3. So this is our rise of 3. We went 1, 2, 3 up, and a run of 1. And that's our next point. So this is our run of 1. And then our line is the line that connects those. So this is slope-intercept form. If our slope is negative, if we have something minus something x, then we just go down instead of up. So for another example, if we have y equals 5 minus 2x, we have a y-intercept of 5, so x equals 0 is paired with y equals 5. Our slope is negative, with negative 2. We can always throw a 1 underneath. So our rise is negative 2, our run is 1. So our y-intercept of 5, our point is 1, 2, 3, 4, 5. And then we have a rise of negative 2. So a negative rise, we go down. So we have 2 hops down. And a run of 1, we'll just go 1 to the right. And our point winds up here. We can actually do this from any point on the line. So we could do this again. Drop down 2, run 1 to the right. There's another point. Drop down 2, run 1 to the right. There's another point. And then our line connects through. So our slope tells us for every one step to the right, this is what we do up or down. Right? So this is just a basic reminder of slope intercept form, looking at it now in the statistics format.